بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه وسلم تسليما كثيرا. أعزائي الطلبة، يتجدد بنا اللقاء في الجزء الثاني من محاضرة Review in IOL Calculation Formulae. The second section of this lecture will concentrate on the fifth generations of IOL formulae. That's those IOL formulae that utilizes the artificial intelligence in the estimation of the predicted value of the IOL. And also we will discuss about special cases like the IOL calculation in keratoconus, IOL calculation in post-LASIK cases or PRK, and also after radial keratotomy. Also IOL calculation in pediatric cataract and IOL calculations in or toric IOL calculations. So I hope that you will get benefit from this lecture, and we will start على بركة الله. بسم الله الرحمن الرحيم. As you know, in the first lecture we covered the introduction and the historical prospect of the IOL calculation formulae, and we discussed different generations of IOL and the derivation of this IOL formulae from theoretical formula to regression analysis and versions formula and the ray tracing formula. Now, as far as the second lecture, we will discuss now regarding the use of artificial intelligence in the calculation of IOL. The common formula are the Kane formula, the EBO formula, the Hill-RBF, the precision Ladas, and the Hoffer QST, and the Pearl-DGS formula. Also, we will discuss the special cases, as I said, that is in keratoconus, IOL calculation, and post-LASIK and BRK and RK, and toric IOL calculation, and also pediatric IOL calculations. Now, the fifth generation of IOL calculation formulae are mainly based on the integration of artificial intelligence in the calculation or the estimation of the effective lens position. And as you know, the artificial intelligence and its application, especially in the field of ophthalmology, has gained huge acceptance between doctors, as the initial results are very promising, especially in the odd cases. When I say odd cases, I mean cases with not within average axial length, or cases with without verging cornea. So cases with extremes of axial lengths, either very short or very long axial length, or cases post keratoplasty or post LASIK ablations. All these are abnormal or special situations. So the use of artificial intelligence formula are very useful in this regard. So we will discuss the Hill-RBF formula, the Kane formula, the precision Ladas formula, and the Pearl-DGS formula, and the Hoffer QST formula to understand the importance of this formula in the next era and the next decade. All the IOL calculation will be based on the artificial intelligence. Now, the first formula in the fifth generation that is utilizing the artificial intelligence is the Hill-RBF formula, which is an online calculator having a website. You can see this is the website you can go through. And it was invented by Dr. Warren Hill. And initially it was as a version 1, then improved to the version 2, and now the version 3 is available, which shows a high degree of predictability as compared to the initial versions. And initially it was tied to the LensStar Hagstrite LensStar 900 and with a special alcohol lenses that's SN60WF. However, now they extend the range to involve a wide range of intraocular lenses. Now, this formula, the initial version, as I say, shows better accuracy than the third generations, but it is not that much accurate as compared to the fourth generations, especially the Olsen formula and the Barrett formula. However, now the third version of it has shown a high degree of predictability and has been tied with different types of nomograms, especially the Toric IOL calculations is linked with this formula. So we will discuss in the coming slides the principle behind this formula and the mechanism of artificial intelligence behind this formula. That's the pattern recognition. And we will see the advantage of this formula. Now, if you go online, this is the education of the website, and as simple as that, that you fill the data needed the website, and it will gives you the IOL power. And of course, you need to optimize your result by following up your cases and applying regression analysis so that you will reach to the best results. Brief background about the utilization of the artificial intelligence in the Hill-RBF formula. Initially, the science or the field of artificial intelligence has been inspired by many doctors and scientists, especially in the United States and Los Angeles and Boston. And they found the applications of the artificial intelligence in the medical field is very useful, especially in the early detection of diseases and also in the follow-up of the diseases. And ophthalmology is one of these branches that has a major applications of the artificial intelligence. And in a future lecture, we will make a special lecture on the applications of artificial intelligence in ophthalmology. As you know, in ophthalmology, the determination or detection of diseases in large extent is made by photographs and by pattern recognition, that you determine the shape of the fundus, the shape of the cup, and so on. So the artificial intelligence is very useful in this regard for early detection of glaucoma and also in diabetic retinopathy and so on. Now, in one of these applications is the use in the IOL calculation, like this formula. It utilizes what's known as a pattern recognition, which is a subset of artificial intelligence, which is known as deep learning. You know, artificial intelligence is divided into a machine learning, which is based partially on a human being and partially based on the machines, and a high degree of deep layer, which is known as deep learning, which is highly sophisticated, mainly dependent on the artificial intelligence and mimic the human intelligence. And a subset of this deep learning is known as the neural network. So the RBF formula, it utilizes this neural network for this purpose, and the system is fed by a large database, and there's a huge statistical variables. The system will, based on the artificial intelligence, will determine the relation between these statistical variables and made a special pattern for these variables. And when we expose the system to any source of data, it will try to compare this data with the pattern stored in the system. And if it recognizes it, it will acknowledge it as in bonds. Or if it does not recognize the data, it will acknowledge it as out bonds. In the coming slides or lecture, you will understand what's the meaning of in bonds and out bonds. But this is as simple as that, the basic principles of the Hill-RBF formula and the utilization of the artificial intelligence. In this slide, I will show the meaning of pattern recognition. As you know that in our daily life, we face some examples of the pattern recognition. As you can see here, this is the pattern recognition in your mobile phone for the fingerprint, your fingerprint. So the same principle is applied when we feed any system with a data, a combination of data. For example, we give a combination of the keratometric power along with the axial length, along with the AC depth, and so on. So the system will create a pattern for these collections of data, and all these patterns are stored in the system. And when we face the system with a particular set of data, for example, for any patients, so he will compare this data with is it recognized by it or not, is it within the normal range or beyond normal range or not, and accordingly it can calculate the power of the IOL and determine the proper IOL formula to measure the IOL. This is as simple as that, the meaning of pattern recognition, or what's known as adaptive learning, that we make the machine learn how to determine a specific pattern of data and determine the statistical relation between these variables, and construct special modules and special patterns to be comparable with other data. In this slide, I will explain the meaning of in-bond calculations and out-bonds calculation, what's known as the boundary of the calculation. Now, the algorithm of the formula combines different variables. For example, this is the sphere equivalent against the AC depth, or the axial length against the AC depth, or the keratometry against the AC depth, and so on. So these two variables, when the data are fed in the system, he organize each two variables and make a boundary for each variables based on the amount and the size of the data fed to the system. Now, when the system is exposed to any data from any patients, he will compare the data given to him by the data stored in the database of the algorithm, and accordingly it will gives you the prediction and gives you the predicted IOL power. Now, if this data is not comparable to any pattern stored in the system, it will gives you an out-bond. It means that the prediction is not accurate because there is no similar data stored in the system. This is the principle or the basis of in-bond calculation and out-bond calculations. Now, if you see, for example, this is a data for one patient with an average axial length and average keratometry power. The green color indicate that the data are in-bond calculation. This is the result in-bond calculation. So the power calculation is predictable and highly accurate because the data submitted to the system is comparable to a similar data stored in the system. So it gives you the green signal and indicate it is in the bond calculation. Now, for another example, if the data is not, because this is the version 1, which has limited data, so sometimes you have odd patient. For example, this is with the very steep cornea around 47 and with a high axial length of 28 millimeter. So one of these variables or two variables are out of bond because they are no similar data stored in the system. So this the meaning of out bonds that the calculation is not as accurate as the previous one because some of the data are missing and are not stored in the system. Now, after the upgrade of the formula and they established the version 2, which includes more data of patients, more than 8,000 data. So the same patient with the same keratometry reading and the same axial length, it gives a green signal that indicate it is now in the bond because the data size is increased. So the increase in the data in the width and the breadth increase the optimization of the data and increase the predictability of the IOL result. Moreover, in the version 3, because the data extends more, so you can see, for example, this is very odd case with a 32 millimeter axial length and strange, very flat cornea. You expect that with this axial length, he should be high myope and he should have a high steep cornea. However, he has a very flat cornea. So even though with this odd presentation, the system gives an in-bound calculation because they increase in the width of the data. So the system can predict what would be the IOL power if it is subjected to this data of the patients. So this is in brief the meaning of the in-bond calculation and out-bond calculation used in this formula. Now in this slide, I will give a brief explanation for the meaning of radial basis functions, which is the principle of the RBF, Hill-RBF formula, without going deeply to this subject, because this is beyond the scope of this lecture. Now, the principle behind the Hill-RBF formula is that it is a sort of a deep learning technology, utilizes what's known as the neural network, the neural network functions. By neural network, it means that if you have two sets of data, these data, if they are linearly correlated, so you can separate them by a linear line. This is the idea. So if you have two variables, for example, the weight against the length, or the power against the weight, and so on. So these data are linearly separable, so we can divide them linearly. Now, the problem arises that if you have a set of data which cannot be linearly separated, for example, the AC depth along with the axial length, along with the corneal power, along with the wide diameter, along with the effective lens position, and so on. So you have a multiple of data that we cannot correlate them linearly. So the neural network means that it is a sort of a deep learning, that we learn the machine deeply to extract this data and rearrange them so that it is arranged in 3 dimensions to be linearly separable. This is the basic principle of radial basis function. So in the Hill-RBF formula, if we have a set of data, this data can be, as I said, whatever AC depth, axial length, or keratometry, the power, the curvature, and so on. Now, there is an input data and there is output data. And in between, this is a subset of neural network. This is a single layer of neural network. So now, based on the input data, the activation of the radial basis functions will correlate a 3-dimensional representation for this data and establish a linear relation between them, and then it gives you an input. And there is also activation of the hidden layer, so that there will be learning of the machine. That's why the Hill-RBF formula is self-validating and self-optimizing and updating itself. So the more the data you enter to the system will learn more and more and can establish a pattern recognition for the set of data, and accordingly it can gives you an effective prediction for the effective lens power. So the system will create like this models. Now this is different models for different set of data. Okay, maybe this set of data, a particular axial length with a particular AC depth with a particular K reading, and so on. And this is another pattern, and this is another pattern. So when you want to test the system, you expose him to any set of data. So he will compare the exposed data with the already stored data in the system, and accordingly he can predict the IOL power. This is as simple as that. I hope that I can reach you the idea behind it. You need not to go deep in this respect. However, just know that this is a sort of deep learning known as neural networking, and it is based on the pattern recognition. This is the basis of Hill-RBF formula. This diagram shows what's known as the optimized surface model. Now, after collecting the data and stored in the system with different variables for the AC depth and axial length and keratometric power, and about 13 variables are stored. Initially, because of the shortage of the data and the small amount of data, the surface for this data appears irregular, and after the data get increased, so there will be smoothing of the surface. So this is a 3-dimensional representation of the data and the parameters of each patient. So you can see clearly after optimizing the data and increase the size of the data, the surface becomes more smooth and more regular. This is called optimization of the surface model. In an assessment of the standard IOL formulas big 5 international studies conducted in different countries in the United States and the UK, Germany, and in United States. And they found that the achieving a 78% of prediction within a 0.5 diopter plus minus has been seen in 78% of the cases. However, a plus minus 1 diopter seen in up to 90% of the cases. So you can see that this is the gap which is still missing, that to achieve a high percentage of accuracy within plus 0.5 diopter of accuracy. And this one, which is the Hagas registry, which is a big formula optimization utilizing more than 300,000 cases, similarly shows that to achieve only less than 1% of the surgeons can achieve up to 92% of accuracy, and less than 6% of doctors will achieve 84% of accuracy, and the vast majority of doctors, they will receive or achieve 78% of accuracy. So this gap to reach 100% or near 100% of accuracy is still there, even with the advancement in the standard optics formula and the versions formula and the advanced formula, but still there is gap for perfection. And this makes the introduction or integration of artificial intelligence is mandatory to improve the accuracy of IOL calculation. This is the initial output of a prospective study conducted in 2016 for the RBF formula, utilizing the first version, and it compares the all eyes and the normal eyes and the patients with axial myopia and axial hypermetropia. You can see the result, a high degree of precision, reaching up to 91% in all eyes, and in normal eyes only up to 92%. And in axial myopia, the percentage is very high, and this is predictable because in axial myopia, usually the IOL power calculation is low, or the IOL number is low, so the chance of error is much low. Any small degree of error in the calculations of any parameter, like the AC depth or axial length, will not result in a high degree of disparity in the power of the IOL needed. However, the reverse is true for the axial hypermetropia, because the power needed in these patients will be high. So any minor degree of error in the calculations of the AC depth or the axial length or the keratometric reading, this will result in a significant change in the IOL power implanted in the patients. So as you can see from this prospective study, that a high degree of accuracy is present in these patients using the RBF formula. This is the first version. However, a much better improvement will be available and published later on in the third version, which is recently published. This study done by the Roman group for the comparison of the different IOL formulas, and you can see clearly that within an average of plus minus 0.5 diopter of prediction error, the Hill-RBF formula achieves around 92% of accuracy, and on a range of plus 0.75 and plus minus 1 diopter, there is 100% of accuracy. So this is really a very high percentage, and indicate that the Hill-RBF utilizing the artificial intelligence shows a high degree of predictability against other standard traditional formulas that uses the theoretical or the regression analysis model. The second IOL formula utilizing the artificial intelligence is the Kane formula, invented by Jack Kane, and it is a blended formula. Blended means it's a combination of versions formula, regression formula, and artificial intelligence, invented in 2017. So we will see what's the specification of this formula.
To be here at the Opto-Hellas booth to introduce the formulas on the Opto-Hellas devices that they're going to be distributing.
The second formula that utilizes the artificial intelligence is the Kane formula, which also belongs to the 5th generation IOL formulae. This is Dr. Jack Kane. He's a young ophthalmologist from Australia who has invented this formula. And I utilize this opportunity to encourage young doctors to be aware of the artificial intelligence and its wide application in the field of ophthalmology, and to be in the future like Dr. Jack Kane. So the Kane formula, it is a blended system that's a combination of both of a theoretical formula with regression analysis as well as the artificial intelligence. And initially it was focusing on extremes of eye, that's very short eyes or very long eyes. As you know, most of the formulae are doing well in the average sized eyes. So initially it was concentrating in the extremes of eyes using various variables like the keratometry, the AC depth, the axial length, and also the lens thickness as a function of the gender, and also the central corneal thickness. And in one study, they compare it with the two famous formulae that is used in extreme eyes, that's the SRKT and the Hoffer Q formula, and it shows a predictability of more than a reduction of more than 25% of the absolute error in long eyes as compared to the SRKT formula. So the Kane formula is very famous in this regard. And this is a study done by Benjamin and Jake Kane to show that the Kane formula is very useful, especially in long eyes. The precision Ladas formulas is one of the newly emerging formulas invented by Ladas and his team. And this is invented in 2015 based on the principle that there are plenty of third and fourth generation formulas over the last 20 years, and they have performed better in special situations. So why not to have a super formula for IOL calculation that can solve all the situations and handle all the situations of IOL calculation in short eyes, long eyes, in post-refractive, and in aphakia, and so on. So he invented this principle by certain mathematical calculations and computations that he could represent these formulas in three dimensions graphically. So by three dimensions, we means that they represent the IOL power and the keratometric power and the axial length in the three dimensions for each of these formulas, like the Hoffer Q and the SRKT and the Holiday one, and so on. And after that, he could superimpose these formulas together and create what's known as the super surface IOL formula. For example, if you can see in this diagram, this is the three-dimensional representation of the SRKT formula. This is one of the famous third generations formula. They represent the IOL power against the axial length and the corneal power. And they did the same thing for each of the formula. In each formula has a potency in particular field. For example, the SRKT is very useful in long eyes for axial length more than 26 millimeter, and the Hoffer Q for short eyes, and the Higgins formulas, for example, for those who need negative powered IOL, and so on. Then he superimposed the surface of each formula and create what's known as a super surface based on the review from literature, the potency and the usefulness of each formula. And still these formulas are undergoing further optimization based on the feedback from different surgeons all over the world. And now they recently integrate the use of artificial intelligence in the prediction of post-operative errors. So different studies have done and shows that it is very useful and shows a promising result, and it is going further optimization and improvement. And this principle is a new concept of a super formula that can handle and all the situations of IOL calculations in different situations, in different cases like keratoconus or in post-refractive surgery and so on. Still in the continuation of the talk about the Ladas formula, they invented a new algorithm incorporated or integrating the artificial intelligence known as the Precision Ladas Universal Super Algorithm, known as abbreviated as PLUS. And this algorithm utilizing the artificial intelligence for prediction of the post-operative IOL power, and it's potentially improving the refractive outcomes after refractive surgery. And it is claimed that it is a dynamic system that undergoes further improvement and optimization based on the data collected from surgeons all over the world. And also it can include different variables like the posterior corneal astigmatism and the corneal thickness. And you can access this algorithm through the internet, through this is the link for the Ladas formula. And this is the interface when you look to the applications and the formula and the interface and the internet, that you can sign in and utilize this formula for optimizing your IOL calculation. The Pearl-DGS method or formula is another formula utilizing the artificial intelligence for the prediction of the effective lens position. And the Pearl stands for Prediction Enhanced by Artificial Intelligence and Output Linearization. And DGS stands for the name of the people who invented this type of formula. They take the abbreviation for the first letters. And it is initially based on the retrospective or regression analysis of the spherical equivalent of the data of the patients after doing the surgeries, and these data are placed inside a special algorithm using the artificial intelligence to determine the effective lens position. And it is meant or solved the problem of the geometric property of the IOL and its relation with the optical results, so that you might have two lenses with the same power, with the same geometry, with the same refractive index, but they have different optical result because of their different anatomical relation to the cornea. And also you might have two lenses with the same anatomical relation to the cornea, with the same power, but they have different geometry, different refractive index, different curvature of the anterior and back surface of the lens, and they will have a different optical result because of the difference in the principal plane. So this is the main principle based on the Pearl-DGS, and it incorporates the what's called supervised learning. This is one type of machine learning that utilizes this formula with a special type of lenses, and it is available on the website as an open source. It is freely available and can be used by any doctors, provided you have the input of the type of the lenses. What you need, you need the anterior and posterior back surface of the lenses, you need the thickness of the lens, and you need the refractive index of the lens. Based on this information, there will be a special equation determines the anatomical location of this IOL. And after determining the anatomical location of this IOL, another algorithm, you will put this data and it will determine the power needed by that type of IOL. So this is another type of artificial intelligence formula used in the calculation of IOL power. Another newly emerging formula that's using the artificial intelligence is known as the Hoffer QST formula, which is an upgrade and advancement of the original Hoffer's formula, which was developed by Dr. Hoffer and his colleagues from Italy. At 2020, the Hoffer QST formula becomes available, and it utilizes the artificial intelligence and also what's known as the pattern recognition to determine the effective lens position. And it has a self-validating tools, and it can do optimization for the personalized AC depth. As you know, the Hoffer formula have gone through various stages of propagations and evolutions from the Hoffer's traditional one, which is at 1974, to the Hoffer Q formula at 1993, then the Hoffer H and the Hoffer H5, and then the Hoffer QST. All are versions formula, but this one is the one which utilizes the artificial intelligence. The Hoffer QST uses various variables as the traditional Hoffer Q formula, but it increases the gender as important variable and the central corneal thickness and the wide diameter. And based on the artificial intelligence, it predicts the effective lens position, based on what's known as the pattern recognition. The Hoffer QST formula is available in the website with an Excel sheet, and there is different varieties like the Hoffer for multiple calculation for different types of IOLs, and also the Hoffer QST RX, which is for the when there is an error in the implantation, you need to recalculate and determine whether you are going to re-implant another lens or piggyback lens or exchange the lens. So you need this formula for the calculation. And as I said, it is available on the website, and you can utilize it. I don't know whether is it freely available or not. I don't know, but this is the website you can go through and check. By this level, we nearly about to finish this lecture. Just I will summarize what we have said before. Generally, the IOL formula can be classified into versions formula and ray tracing formula and artificial intelligence, and a combination of all these together. In the coming slides, I will give a brief summary to what we have given and to understand where we are now. And then we will speak about the special scenario and special cases like in post-LASIK ablation, IOL calculation, and also in keratoconus and in pediatric cataracts. Now all doctors and senior doctors, including me, are familiar with the commonest formulae that we were using before 2010, which is the most common was for short eyes, the Hoffer Q formula, and for long eyes, we use the SRKT formula. And we were happy with the result at that time. And at the end of 2010, the holiday formula came, but it was not that popular at that time. After 2010, plenty of formulae were available in the market. The Barrett Universal 2 gained popularity, and the Pearl-DGS formula and the Olsen formula, the Nasser 2 formula, and plenty of formula like the Kane formula. But at that time, still there was no comprehensive studies that accurately gives the accuracy of these formulae in the prediction of effective lens position. So some doctors are using them. Some are still stuck to the third generation and fourth generation IOL formulae, so that they keep utilizing what they know about these formula. And many studies are conducted at that time to assess the efficacy of these formulae. At 2017, a study conducted by Millis et al. And Jack Holliday was a co-author for this paper. They study more than 13,000 cases. They compare the 7 major IOL calculation formulas, including the new generations and the old traditional IOL formula. And they try to find out which one is better for estimating the effective lens power over a large range of axial lengths. And they discovered also that still the Barrett Universal 2, it holds better, and it do better over a wide range of axial lengths, either the average size eyes or over the extremes. And they became happy to continue using the Barrett Universal 2 formula as a very accurate prediction for the IOL power as compared to the other formulas. As you can see, the result of the comparison of the 7 most popular IOL calculation formulas over the whole range of eye axial length dimensions, that the universal or the Barrett universal 2 is the most accurate one, that shows 50% of the patients within a 0.25 diopter of sphere equivalent, and shows up to 80% of the patients within 0.25 to 0.5 diopter of sphere equivalent, and up to 90% of the patients up to 0.75. And the second step comes the Olsen formula. So this study shows that the Barrett universal 2 is the most accurate among the most popular 7 IOL calculation formulas available in the market, and it shows high degree of accuracy and high degree of prediction of post-operative IOL calculation power. At 2019, the same group, Ronald and Melis et al., and now with Jack Kane, they did the same study to compare the different formulas, the new and old generation formulas, and they came up with the result that Kane formula do better as compared to the old generation formula, with just 10 to 15% more accuracy as compared to the old formula, as you can see here in the right column. And however, the Kane has much degree of predictability, and followed by Olsen formula, but Olsen formula, because it is a paid formula, so it is not used commonly now. So the Kane formula shows better result than Barrett formula, as well as better than the old generation formulas. At 2022, another important study done to compare the efficacy of different IOL formulae in cases of high myopia with large axial length. You can see here cases of more than 29 millimeter axial length, and this case more than 31 millimeter axial length. And they compare the EVO, Kane, Olsen, Barrett 2, SRKT, and Hagas formula. And the result came that the initial four formulas, that's the EVO, Kane, Olsen, and Barrett 2, has a statistically significant accurate post-operative result as compared to the old generation, that's the SRKT and Hagas formula. So from the previous discussion, you can understand that the current era is concentrating on those formulae which are integrating the artificial intelligence to include all ranges of axial length. As you can see here, the Hill-RBF can be used over very short eyes, as well as in very long eyes with some modifications. And still this formula is growing up, and the result is very promising. Also, the Barrett Universal 2 undergoes continuous upgrade and improvement, and you can see that it is used over a large range of axial lengths. Olsen formula also it holds better over average size, as well as long eyes and short eyes, as it relies on the ray tracing principle. And Holiday also is very good over wide range of eyes. All the formula, especially the new generation, which utilizes the artificial intelligence, are doing well. So I expect that the next era will be the formally that uses the artificial intelligence, and the old generation with time will disappear. Now, to summarize what I have said earlier, that in average sized eyes with average axial length, that's between 22.5 millimeter up to 26 millimeter, all the formulae, either the third generation, fourth generation, or the fifth generation utilizing the artificial intelligence, are doing good. However, the trend toward using those formulae which utilizes the artificial intelligence is gain large popularity between doctors, but all the formulae are doing well in average sized eyes. Now, for short eyes, the short eye means less than 22 millimeter. If you don't know the AC depth, better to go for Hoffer Q formula. Otherwise, if you measure the AC depth, but you have an axial length more than 20, you go for the Hoffer Q Holiday 2 or the new generation, that's the Hill-RBF formula and the Evo 2. If you don't, if it is less than 20 millimeter, so you go for Kane formula, Evo, and Higgins formula. This is as far as the short axial length eyes. Now, for the long axial length, means more than 26 millimeter. If it is less than 30, that's more than 26, but less than 30 millimeter, you can use the SRKT and Higgins formula, provided you arrange the post-operative target refraction. Also, the Barrett Universal 2 can be used. Now, if it is very long eye, that's more than 30 millimeter, very high myope, the Barrett Universal 2 and the other new formula that's utilizing the artificial intelligence with ray tracing like the Olsen formula, provided you adjust the target refraction to be in minus 0.5 diopter. So you can understand that in average size eyes, you can use whatever. In short eyes, the Hoffer Q is the most popular, and long eyes, the Universal Barrett Universal 2 is most popular. Now we come to the last session of this lecture, which is the IOL power calculation in special cases. After we finish speaking about the normal cases with different axial lengths and all the generation of IOL formulas, and we make a summary for the indications and the difference between the different formulae. Now I will speak in details about special situations. For example, the Toric IOL calculations and the post-operative cases, that's we post-refractive cases, and also in keratoconus, how to measure the IOL in keratoconus, and also the IOL calculation in pediatric cases. Of course, there is another important subject like the combined keratoplasty and cataract, or DMAC and cataract. I will not speak in details about them now. I will speak only in these four subjects, and especially the Toric IOL, because this is gained special attention by all doctors, because the incidence of surgical induced astigmatism is there nearly in most of the cases, and to get a very good result after cataract surgery, which is now a refractive surgery, we need to handle this issue of the Toric IOL calculation, especially with the advancement of the machines that can measure the posterior surface of the cornea. Before I go to the details of the Toric IOL calculations, there are certain terms I would like to emphasize. Two terms very important: the residual postoperative astigmatism and the surgically induced astigmatism. Now, the residual postoperative astigmatism is a combination of both the preoperative corneal astigmatism that's present before the surgery, and what's known as the surgically induced astigmatism that is induced by the surgery itself. And the surgically induced astigmatism can be subdivided into a corneal component and lenticular component. The corneal component is due to the wound construction and the wound location itself that induces astigmatism, and the lenticular portion, which is due to the either IOL tilt or decentration or misalignment of the lens, or wrong calculation of the lens itself may induce some astigmatism. So surgically induced astigmatism is included in the residual postoperative astigmatism. So the residual postoperative astigmatism is a combination of both the surgically induced as well as the preoperative refraction of the patient. So for the surgically induced astigmatism, ideally surgeons should calculate their own surgically induced astigmatism based on the common way they use in the construction of the wound, the size of the wound, the location of the wound, and by that way they can predict how much they induce astigmatism in their patients. And this is very important. When we go to the Toric calculation, you will find that you need to input the surgical induced astigmatism by the surgeon. So this is very important. Another way to estimate your surgically induced astigmatism is there is special calculators known as SIA calculator, that's surgical induced astigmatism calculator, in which it will estimate your surgically induced astigmatism based on the data you feed to the calculator. including the location of the wound, the size of the wound, and the keratometry and the refraction of the patient. So they will inform you how much average surgical induced astigmatism you induce to your patients. So this is two important definitions should be kept in mind: the residual postoperative astigmatism and the surgically induced astigmatism. Now, how we measure the corneal astigmatism. As you know that the K1 and the K2 represent the anterior surface of the cornea. And when we want to measure the corneal astigmatism, we take the K1, which represent the steep meridian, and the K2, which represent the flat meridian. And we subtract these two values, and we use the x of the steep meridian. For example, in this case, the difference between the K1 and K2 is 2 diopters, and we will take the x of the steep meridian, which is 85 degrees. And this value, as I said, this is represent the anterior surface of the cornea. That's why machines that using the Placido's disc or the manual keratometry or the autorefractive keratometers, they usually gives the K1 and K2, which represent only the anterior surface of the cornea. And for any toric IOL calculation, it is mandatory to include the posterior surface of the cornea. Now, what's the importance of the posterior surface of the cornea? They found that one of the major source of errors in the residual postoperative astigmatism is not to take in consideration the posterior surface of the cornea, because although it is of little value, small amount at the corneal plane, but this is different at the lens plane. So for any accurate toric IOL calculator, consideration of the posterior surface of the cornea is very important. And the difference between the different machines, for example, the IOL Master 700 or the different topographies, based on their estimation or the prediction or the accurate measurement of the toricity of the posterior surface of the cornea. And because the posterior surface of the cornea, the refractive index of the cornea differs than the aqueous, so it is usually act as a negative meniscus lens. So the astigmatism in the posterior surface of the cornea commonly against the rule and usually act as a negative meniscus lens. For example, if the same patient here, the posterior surface of the cornea is minus 0.5 diopter at the same axis, that's 85 degree. So the total power of his cornea will be equal to algebraic sum of the anterior surface of the cornea, and this is the posterior surface of the cornea. So the total astigmatism of this patient will be around plus 1.5 diopter at the axis of 85 degree. Now, just keep in your mind that if your patient has with the rule astigmatism in the anterior surface of the cornea, so the posterior surface usually against the rule astigmatism. So the net power of this patient will be reduced by about 0.5 degree in the axis of 180 degree. However, if the patient, the anterior corneal astigmatism is against the rule astigmatism, and also the posterior surface, which is commonly against the rule astigmatism, so the net astigmatism of this patient, we will need to add another positive value of around 0.3 at the axis of 90 degree. So this is in brief how we measure the total power of the cornea and estimate the total corneal astigmatism, that's including both the anterior surface as well as the posterior surface. In this diagram, I will show the relation between the anterior surface of the cornea and the posterior surface of the cornea. The anterior surface of the cornea act as a positive lens, and majority of the people, they have with the rule astigmatism. That's the vertical meridian is steep as compared to the horizontal meridian, and usually this with the rule astigmatism change with age, and by the age of 50 and more, it changed to against the rule astigmatism. However, when you look to the posterior surface of the cornea, it acts as a negative lens or a negative meniscus, and usually it ranges the power between minus 0.3 to minus 0.5. Usually this is the common average, and it does not change with age. Usually it retains always against the rule astigmatism. Of course, if there is any change in the astigmatism here as far as the power, also the astigmatism here will be changed. But this is what we speak about, the average normal people. So you can see from this picture that both the anterior surface and the posterior surface, they compensate each other. They compensate each other. Of course, after taking in consideration the astigmatism present in the lens. Now, if you ask me why the anterior surface of the cornea is positive and why the posterior surface of the cornea is negative, and the answer is related to the refractive index. Now, the anterior surface of the cornea, the air has lower refractive index as far as the cornea, so the rays will be converging when they go to the anterior surface of the cornea, so that the anterior surface will act as a positive lens. However, in the posterior surface of the cornea, the relation between the cornea and the aqueous has a lower refractive index as compared to the cornea, so the rays will diverge when they go from the cornea, so that it acts like a negative lens. Another important point that should be understood clearly, that whatever power we are speaking at the level of the cornea, this power is not the equivalent at the level of the lens because of the anterior chamber depth. As you know, when we spoke about the effective lens position, as we move backward toward the level of the lens, now the power will be changed, and this is related to the anterior chamber depth and to many other variables. So the power correction at the level of the cornea differs than the power at the equivalent power at the lens. And this is known as the lens plan, which is related to a correction or refractive factor by around 1.5. So any power at the level of the cornea is multiplied by 1.5 to give you the equivalent power needed at the level of the lens. This is called the refractive factor. So this is a rough estimation that is around 1.5 because it depends on the AC depth and also on other constants based on the lens, and also differs based on different IOL calculators. So this is very important to keep it in mind, either in two directions. Either you want to move the power from the level of the cornea to the level of the lens, or if you have any amount of residual astigmatism due to the lens and you want to convert it to the at the level of the cornea so that you correct it by glasses or by contact lens, you should remember this correction factor because of the depth of the anterior chamber. So if we combine the ingredients, that's the preoperative astigmatism and the surgically induced astigmatism, this will give us what's known as the projected postoperative corneal astigmatism. And projected postoperative astigmatism is the amount of astigmatism at the level of the cornea. And if you want to correct it at the level of the lens, this amount will be, of course, differs because there is the anterior chamber, as I have explained. So based on our understanding of the origin of the surgically induced astigmatism and the contribution of the posterior surface of the cornea in the total astigmatism of the eye, so an ideal IOL calculator or IOL calculation formula for the toric astigmatism or toric IOL, this formula should take in consideration the exact axe and the power of the toric lens that needed to be used for the correction, as well as we have to estimate the surgically induced astigmatism to be included in the equation. And also we have to estimate or measure the posterior corneal curvature and astigmatism. And finally, we have to estimate the effective lens position. So all these four variables are determinantal factors in accurate calculation of the post-operative astigmatism and accordingly to plan for a toric IOL correction. Another important subject I would like to highlight before I go to the different IOL calculation formulas, which is the graphic representation of the astigmatism. As you know, astigmatism is not a single magnitude value, but it is a value associated with a direction. So it is named as a vector. Vector means it has a direction and it has a magnitude. And this graph, as represented by Cox and his group, describe the residual predicted postoperative astigmatism in terms of centroid defect. And by centroid, it means the value which is represent all these graphic vectors. Because, as I said, the astigmatism is represented as a vector. The vector has a magnitude, ranges from 0 up to 0.25. This is the first ring. The second ring, 0.5. 0.5, then 1, then 1.25, so on. Each ring represents 0.25 diopters. And this is the degree which represent the direction of the vectors. Now, if you have plenty of data and you want to represent the astigmatism in this polar representation, this is called polar representation in contrast to the Cartesian representations. The representation will appear as this. Now, how can you take the mean or the median of these values? Now, the centroid represent the median for all of these values. Now, to understand this, I made an example. If you have a patient with 0.3 diopter at the x of 20 and 0.35 diopter at the x of 110. Now, if you take the mean by the traditional way, so the mean will be equal to 0.3 diopter. However, actually, the mean vector for this patient is equal to 0 because the first value, which is 0.35 diopter at the x of 20 and the other at the x of 110, so the net will be equal to 0 in this point. So the net centroid for this patient will be equal to 0. So this is the best way to represent astigmatism in a centroid configuration or in a polar configuration like this, represent better description of the value as well as the magnitude. So it gives the mean of the vector, not just the mean of the magnitude itself. For more detailed information about this subject, you can refer to my published paper on the vector graphic analysis of postoperative astigmatism after cataract surgery that I have published in 2008 in the Medical Journal of Cairo University. There is detailed description of this method, and also there is a special software that calculates for you the vector representation of your astigmatism. To know how to measure the posterior corneal astigmatism, there is different methods to measure the posterior corneal astigmatism, either a direct way or indirect way. The indirect measurement is by using a special nomograms based on the keratometric readings. There is special nomograms like the Baylor nomogram and Abulafia-Koch nomograms. This is a traditional and old one used to predict the posterior corneal astigmatism. Also by special regression formula is available to predict the posterior corneal astigmatism. And also there is online calculators like the Barrett calculator and the Alcon Toric calculators. The direct measurement way, which is using the sham-flock technology like the Pentacam, or using the swept source OCT like the IOL Master 700 measures the TK, which is the total keratometry power. So this is a direct measurement of the posterior corneal astigmatism. However, the initial one was indirect measurement based on the anterior K reading, so they can predict the posterior corneal curvature. Of course, this is the indirect measures based on the normal relation between the anterior surface and the posterior surface of the cornea, so cannot be used in cases of altered posterior surface or altered anterior surface, like in cases of post-LASIK or post-radial keratotomy. However, the direct measurements, because it is directly measuring the curvature and the power of the anterior and posterior surface, so it can be used even in cases of post-LASIK and cases of radial keratotomy. Another important point that I would like to speak that make confusion within doctors is the different types of K readings, and the different terminology is used by different companies and different machines, and this make a little bit of confusion which K reading that you have to use and which formula to use and so on. So this is very important because for Toric IOL calculation we have to use a special K reading that take in consideration the posterior surface of the cornea. However, in the traditional IOL formula for the spherical IOL implantations, we use the simple K reading that utilizes the anterior surface of the cornea. So I will speak just on two machines, that's the Pentacam and the IOL Master 700. As you know, the Pentacam is a sham-flock device that uses the sham-flock technology or camera to measure both the anterior and posterior surface of the cornea. The first terminology is what's called the total corneal power. Now, the total corneal power measured by the Pentacam refers to the power measured from both the anterior and posterior surface of the cornea. and it utilizes the real refractive index of both the anterior surface of the cornea and posterior surface of the cornea. The real refractive index, which is 1.375, which is the real refractive index, not the assumed refractive index, which is used to measure the SIM-K. The SIM-K is measured by an assumed refractive index, that's 1.3376, and that's why to overcome or take in consideration the posterior surface of the cornea. As you know, the SIM-K does not measure the posterior surface, but it measures the anterior surface and uses this assumed refractive index to give an idea about the posterior surface. This is the point. However, in the Pentacam, because we can measure both the anterior and posterior surface directly, so it measures it with the real refractive index, that's 1.375, and also for the posterior surface of the cornea with the real refractive index, so that we have both the power of the anterior and posterior surface. When both powers are added together, it gives you the total corneal power. Now, this measurement is taken by the direct measurement based on the radius of curvature of both the anterior and posterior surface of the cornea. Another point is the total corneal refractive power. Now, what's the difference between the total corneal refractive power and the total corneal power, TCP and TCRP? The total corneal refractive power, the same principle. It is the measurement of both anterior and posterior surface of the cornea, but instead it is based on the ray tracing. And also it utilizes the real refractive index, that is 1.375. And by ray tracing, it differs than the total corneal power, which is based on the radius of curvature only. Now, by the ray tracing, it takes in consideration all the corneal power with regard to the different corneal thickness in the cornea. So it is more accurate representative of the total corneal power of the cornea. That's why the TCRP is preferred for toric IOL calculations using the Pentacam. You will notice that most of the IOL formula will ask you for this K reading, that's the TCRP. This is very important in toric measurement or toric IOL calculation. Now, the other term is the equivalent K reading, which is used or introduced by Holiday report, and this equivalent K reading, it is done to overcome the problem and the confusion that happens between doctors to utilize the simple K reading in the traditional IOL calculation formula, or to use the K reading that is measures or estimates the power of the posterior surface. So what he did, Dr. Holiday, he measures both the anterior and posterior surface of the cornea, and by certain mathematical calculations, he accepts 65% of the data of the posterior surface of the cornea. After, of course, he's measuring using the real refractive index. So he omits about 35% of the data, and he assumes only 65% of the data, and it gives you an equivalent K reading that can be used in any IOL calculation formula. So it takes in consideration the posterior surface of the cornea, but it will preclude some of the data and use only 65% of the data, take 65% of the mean of the data, or 65% of the median of the data. So that this K reading can be used in any IOL calculation formula. There is no any confusion, because the total corneal power, TCP and TCRP, cannot be used in any traditional IOL formula. If you use this K reading in any traditional IOL formula, this will lead to double estimation and lead to a wrong calculation, because all the traditional formula are based on the Gaussian optics and based on the principle of the K reading, utilizing the presumed refractive index, which is 1.3376. I hope it is clear now. So Pentacam uses the TCP, the TCRP, and the EKR65. What's important for us is this one, which is TCRP for the toric IOL calculation. Another point that you will notice that the estimation of the total corneal power using the posterior surface of the cornea, the value will be less than the K reading, because the posterior surface of the cornea is a negative value, and it uses another refractive index. For example, if you can see here, this is the SIM-K reading, you using the tangential map using the simple K reading, you find the K reading here is 47. However, the total cone TCRB power is 46 here. This is the total or net power map. You will find it is 46. However, the simple K reading, but using the tangential or axial map, you will find it is 47 here. So what I want to say that the total corneal power map is less than the power map using the axial map. The sim K or the K reading of the anterior surface of the cornea is more powerful than the K reading using the RCB. I hope this is clear now. Again, this is a confirmation to what I have said earlier about the difference between the SIM-K and the TCRB map. The SIM-K utilizes the presumed refractive index, and it gives idea about the anterior surface of the cornea. And the total corneal refractive astigmatism is measured by the TCRB map, and this takes in consideration both the anterior corneal astigmatism and the posterior corneal astigmatism. The SIM-K reading, you will find it here in the first row, and the total corneal refractive power map or readings you will find here in the third row. And this is what the effective K reading that I have explained earlier that it gives you information about the anterior and posterior surface of the cornea, but this K reading can be used with any IOL calculation formula. This map, the EKR 65 and the TCRB are special and peculiar to the pentacam. So if any IOL calculator asks you for this, it means that it is related to the pentacam. Another important term I would like to explain, that is the total keratometry, the TK value. Now this term came after the invention of the IOL Master 700 at 2019, and this K reading based on the anterior and posterior surface of the cornea, but at the same time by particular mathematical calculation and assuming the Gaussian principle, it gives you the K reading that is can be used with any traditional IOL formula. I will explain this in details. Now the TK or the total keratometry, it measures the anterior surface of the cornea, and based on the corneal thickness, it measures the intracorneal distance, so it can predict or estimate the posterior surface of the cornea. And after estimation of the posterior surface of the cornea, it gives what's known as posterior torus fit. And accordingly, the machine will construct the shape of the anterior and posterior surface of the cornea. But this is not the end of the story. After it have an idea about the posterior surface of the cornea and anterior surface of the cornea, by assuming the keratometric index that's 1.3376, which is the old erroneous refractive index which is used before. So it gives you the total corneal power, but based on the presumed refractive or keratometric index 1.3376. So the idea behind this is that to give you an equivalent K reading that can be used with any traditional IOL calculation formula. So now if you ask yourself what's the difference between the TK value and the pentacam total corneal refractive power map, that's TCRB. Now in the TCRB, it measures the anterior and posterior surface of the cornea by the method of ray tracing, and it assumes the normal and the real refractive index, that's 1.375. So that K reading cannot be used with any traditional formula, because all the traditional IOL formulas are based on the assumed refractive index or keratometric index, that's 1.3376. So the TK gives you an estimation of the anterior and posterior surface of the cornea, but using the what's called the swept source OCT, and also it uses the what's called telecentric K reading. And I have explained about the telecentric K reading in the lecture of optical biometry and the different machines used for optical biometry. You can refer to that lecture. So in summary, both the total corneal refractive power map by Pentacam and the TK value by IOL Master Zeiss 700, both they measure both the anterior and posterior surface of the cornea. However, the TCRB power map cannot be used in any traditional formula because it uses the real refractive index of the cornea. However, in the IOL Master, they measure the anterior and posterior surface, but by certain mathematical calculations, it gives you the total corneal power, but based on the assumed refractive or keratometric index, that's 1.3376. The idea behind that is that they will give you a K reading, including that taking consideration both the anterior and posterior surface of the cornea, but at the same time can be used with any traditional IOL calculation formula. I hope this is clear now. The other thing is that so the TK value is equivalent to the K reading because it is measuring both the anterior and posterior. So it can be used with any standard IOL formula, and it is based on the Gaussian ratio or Gold-Strand ratio. What's meant by Gold-Strand ratio? You remember when we speak about the curvature of the anterior surface and the posterior surface of the cornea, we say that the ratio between the curvature of the posterior surface to the anterior surface is about 0.82. That's the posterior surface is more curved as compared, the radius of curvature is more, and it is more curved as compared to the anterior surface of the cornea. So the TK value is used with any traditional IOL formula, but in some IOL formula, they will ask for the TCRB, that's the total corneal refractive power map used by Pentacam. So, for example, in the Barrett universal formula, you cannot use the TK value because the TK value cannot use it in the Barrett universal formula. However, there is another formula made by Barrett, is the Barrett Universal TK formula. When they say TK, it means that you can use the TK value in the Barrett Universal TK formula, and so on. I hope this is clear now. This is another example to understand what I have said earlier. For example, this is the printout of the IOL Master Zeiss. You will find the reading of the TK value here for TK1 and TK2, and also the K reading. Okay, so the TK value represents both the anterior and posterior surface of the cornea with a special consideration using the presumed index, and the K value is just for the anterior surface of the cornea. So now the importance that you can use the TK value in any old IOL formula, you can use it, there is no problem. Previously, they were saying that some formula like the Barrett universal formula, they take in consideration the posterior surface, so TK should not be used. However, many studies done, they show that there is no statistical significance between the K and the TK value in normal average size eyes. The problem arises in abnormal corneas, like in post-LASIK or post-keratoplasty, or in in cases of keratoconus. Now, in these cases, the consideration of the TK is very important. There is difference between using the TK or the K value. However, in normal eyes, there is no statistical difference. As I will show you in the next slide. This another thing that there is what's known as the true K. Now, the true K is used for post-LASIK cases. Now, this term is used by Barrett to describe the real curvature of the anterior and posterior surface of the cornea in post-LASIK. Why? Because in post-LASIK, the relation between the anterior and posterior surface is totally altered. So the true K refers to the real curvature of the anterior and posterior surface of the cornea, is not related to the Gold-Strand ratio, which is 0.82. So true K is another term used by Barrett Universal, and is just only describes the corneas that underwent LASIK correction. As I said earlier, that many studies done to compare the application of K reading and the TK value, both in Hagas formulas and Barrett universal formula, there is no statistical significance in a normal eyes. In a normal eyes, there is no any statistical difference between using the K or the TK value. However, the importance in abnormal eyes like in keratoconus and post-LASIK ablation. Before I speak about the different calculators, Toric IOL calculators, I just want to remind you about the source of error in the Toric IOL calculation. Now, after you understand the problem of corneal astigmatism, the anterior and posterior surface, and the dilemma and the problem in the measurement and the different machines that measures the anterior or posterior surface, and also about the surgically induced astigmatism and how can we predict the surgically induced astigmatism, and also about the alignment of the toric IOL. All these variables are very important to have an accurate correction of the patient's astigmatism, especially if the patient has a small value of astigmatism, for example, minus 0.75 or plus 0.75. Now, any minor mistake may result into a refractive surprise and end up with an unhappy patient. So accurate and precise measurement should be taken into consideration in the decision making. Now, what are the common IOL calculators available? The most common IOL toric calculators made by famous companies based on the manufacturing of their lenses. So each company has its own online calculators, like the Abbott, the Alcon, the Askers has also an online calculator, the Abasami company also, and the Orolab, and so on. And of course, the Barrett toric calculator. This is one of the famous IOL toric IOL calculators. So all these are available online and will help you to measure the toric correction for your patients. Among the most common online toric calculators available in the market is the Barrett toric calculator. That's why I will speak some of few words about it. It is a theoretical formula enforced by data regression or regression analysis, so that it gives a high degree of precision, and it is one of the most accurate formula available in the market. And it is measuring the posterior corneal astigmatism. Actually, it predicts the value of the posterior corneal astigmatism. It measures the anterior corneal astigmatism, but it predicts the posterior corneal astigmatism. And they say that there is no superiority of the measured value of the posterior corneal astigmatism over the predicted value. And now recently incorporated in most of the IOL biometer machines, and also available in the Askers website and the EBA CRS website. And also another version available for post-LASIK cases called TrueK. Whenever you find the TrueK, means post-LASIK. So there is a TrueK toric calculator for cases of residual astigmatism after LASIK correction. The good thing and the good advantage of this formula that it allows you to make input the data from more than one machine. For example, from the lens star, you put the data from the lens star, also put the data from IOL master, and then from the topography, and the machine will calculate the average astigmatism for these patients and gives you the ideal IOL power and X for that patient. So it utilizes the input from 3 different machines. This is the Barrett toric calculator. Now there is another important calculator for the residual astigmatism after toric IOL. Now suppose in case you implant a toric IOL and by mistake you have a residual astigmatism, either because of wrong calculation or from the misalignment. How you know that you are your lens is rotated or not? So there is a special online calculator known as the astigmatismfix.com. And you will feed the system with the data you have, including the manifest refraction, and accordingly it will tell you whether you need to rotate the lens or not to rotate the lens, so that to correct this residual astigmatism. Now the second important topic that requires special consideration as far as the IOL power calculation is the power calculation in post-refractive surgery, either in the form of LASIK or BRK or radial keratotomy. The subjects gain large importance by many doctors because of the risk of high refractive surprises after IOL implantation due to the imbalance between the anterior and posterior surface of the cornea after these procedures. So in the next slides, I will dive deeply and speak more in details about this subject. In this slide, I will speak about one of the main difference between radial keratotomy and LASIK ablations. As you can see here in this animation, that in LASIK, we flatten the anterior surface of the cornea. However, the posterior surface is not affected, so the changes only appears on the anterior surface of the cornea. However, in radial keratotomy, the incisions done here in the cornea will affect both the anterior surface as well as the posterior surface, and a flattening effect will affect both surfaces. So this is very important in consideration because when we study the K readings, you should understand the difference between the K reading in post-LASIK cases, that it mainly changes the anterior surface. However, in radial keratotomy, it affects both the anterior and posterior surface. So, as you know, the radial keratotomy has been invented many years back by Dr. Vidorov from Russia, and they gained a large popularity, although now it is no more practiced by the advancement in the LASIK procedures. But now the patients who had did these operations 30 or 40 years back, now they reach to the age of cataract, so they have lens changes along with this shape of the cornea. So we still facing some cases coming with cataract who had underwent radial keratotomy. That's why this subject is still important. Now, by understanding the basic principles behind the LASIK and radial keratotomy and the effect in the anterior and posterior surface of the cornea, now we should take this in consideration because this will create a source of error and a source of challenge in the accurate calculation of the IOL power. For example, the refractive index of the cornea is no more valid because the presumed refractive index of the cornea, which is 1.337, this index was based on the Goldstrand principle and the reduced eye model, where there is a normal relation between the curvature of the anterior and posterior surface of the cornea. However, in post-LASIK and in radial keratotomy, now this relation is disturbed, so we cannot depend on this presumed index model. So we have to use the real refractive index of the cornea, which is 1.376. So if you don't take care of this, so this is a major source of error. Another thing is the device error. Now, by device error, I mean that the normal keratometry or the manual or automated keratometry, it measures the ring of between 2.5 to 3.2 millimeter. So it doesn't measure the central 1 to 1.5 millimeter, which is the location of the most flattening part after LASIK or after radial keratotomy. So the simple keratometric reading is not representing the central point of the cornea, which is the source of flattening in LASIK and radial keratotomy. So we need to use another machine. The other machine is the topography. Now, the same problem in placido disc-based topography, the very central point of the cornea cannot be measured, but it is extrapolated by the machine because that location is containing the camera of the machine, which measures the mirrors or the rings of the light on the cornea. So they measure the adjacent areas, and the central, very central point of the cornea is extrapolated. So it doesn't give a real calculation of the central 1 to 1.5 millimeter zone of the cornea. Now, the best device to solve this problem is the elevation-based topography using the Scheimpflug technology. So the pentacam will give a real estimation of the power of the cornea in the central zone of 1 to 1.5 millimeter. So it gives a good estimation for a central zone rather than a ring. So this should be taken into consideration. So using the elevation map from the pentacam is better than using the placido disc topography. Now, another source of error is the formula. Which formula you are going to use? Now, you know that all the formulae are using the standard K reading, which uses the presumed refractive index or keratometric index. which, as I said, now it is not valid anymore. So we have to use another source of keratometric reading to be placed in the compatible with the IOL formula. And I think that the best one is the EKR 665, as I explained in the lecture of the topography. Now the EKR 65 by Pentacam, it measures the anterior and posterior surface of the cornea by ray tracing, and it uses the new refractive index, which is 1.375, and it gives you an equivalent K reading that can be used with the standard IOL formula. So by this way, we solve the problem of the keratometric index, and we solve the problem of the measurement of the anterior and posterior surface of the cornea. And at that time, a better prediction of the IOL power can be done. Now, if you don't take this in consideration, the risk of hyperopic surprises becomes inevitable, because you cannot measure the exact central point of the cornea, and this might be a major source of error in the IOL calculation. Now I will speak about the formula that's used for measuring the IOL power in post-radial keratotomy. As I have explained before and mentioned before, that radial keratotomy was popular during the 1990s, and it was invented by Dr. Vidarov, and it became popular at that time, the age of the patient around 25 to 30 years, and now most likely they are around 60s. So now at the age of cataract. Now these patients, they need or they have high expectation from the cataract surgery, as they have received this expectation from the radial keratotomy. So accurate measurement of the IOL power in this patient is very important, and the tolerance for any error is not acceptable by these patients, because they need to be a spectacle independent for far vision as well as for near vision. So any underestimation or recalculation of the power of the IOL will result in hyperopic surprises, and this will not be acceptable, and you will end up by unhappy patients. So precise and accurate measurement of the power of the IOL in these patients is very important. Now, when you remember the challenging point that we have spoken about, the post-radial keratotomy, the problem in measuring the corneal power, especially the anterior and posterior surface of the cornea. So most of the methods are either they are based on the historical record of the patient, the original record, the preoperative K reading, or the preoperative refraction, which is called the true K method. And this depends on the historical data from the patient, provided the original records are available. Now, other formulas are based on those machines who are able to measure the posterior surface of the cornea, which is the Pentacam and the IOL Master. So that we have the DK Holiday IOL Master formula, which uses a standard K reading, which is around 43.86, and accordingly it estimates the power of the IOL. Or the Potvin-Hill formula based on the Pentacam measurements, so that it can predict the power of the IOL. But the American Academy of Cataract and Refractive Surgery makes things are simple. Just you have an online calculator that you feed the system with the data, either you have the historical data is available, or if it is not available and you have the current data, you just feed the online calculator with the available data you have, and it will measure the IOL power for you for these patients, and becomes as simple as that. So the most popular now is to use the online calculator to have accurate prediction for the IOL power in post-radial keratotomy patients. Now, what are the different IOL formulae to be used in the post-refractive surgery? Of course, this is a very big subject that it needs a separate lecture for this, but what I would like here to show you the huge effort and the attempts made by doctor to achieve an ideal IOL formula to predict exactly the IOL power in post-refractive surgery. And there are different principles based on these formulae. I will not go to the details of each formula, but just I would like to show you that this subject is gaining importance by most of the doctors, and the prediction is still not that high to a large extent as in a virgin cornea. So broadly can be classified into those formulae which are based on a historical data. When I say historical data, I mean the preoperative refraction and the preoperative K readings. And those which depends on both the preoperative and postoperative refraction and the K readings, and those which with no any history, preoperative history. And this is the common in the current situation, that the patient came to you without any prior history of K reading or refraction. So you can see that there is a huge battery of IOL formula, but the most common one is the one which is using the ray tracing, as you can see here. The ray tracing formula. This is the new trend that shows a high degree of accuracy, utilizing the total corneal power map using the pentacam, or they're using the TK value from the IOL Master 700. Now, thanks for the Ascaris website, which provide calculator that can simplify life for us and becomes more easy, that utilize the ideal IOL power calculation formula based on the data available to you. So broadly, if you can have, or if you can measure the posterior curvature of the cornea, you can use the Barrett TK, Barrett True K TK formula, or use the OCT based formula, or the Hagas TK formula, and the ray tracing formula using the OCT or pentacam, or the EVO formula, or the Botwin Hill formula. Now, if you cannot use the, you cannot measure the posterior curvature of the cornea, so this is the different formulas that you can use: the Barrett True K with history only of the changes in the refraction after surgery, or Barrett True K without any history, or you can use an intraoperative biometry that I will speak about it later on, and the Hagas L formula using the ray tracing, and the Shamas formula. Now, these formulas does not need history, prior history. So if the patient just come to you at once and he tell you that he did the refractive surgery, so you can use these formulas, which is highlighted in the yellow square. This does not need any prior history. And as I said, the IOL calculator for the post-refractive cases is available in the website of the Ascaris website, and you can use the different formulae based on the data available to you. Here I want to speak about one of the most important technology available currently, which is the intraoperative biometry. Now, when you have a patient that you cannot accurately predict the power calculation before surgery, for example, as I said, post-refractive cases, or especially in patient when you are going to do combined keratoplasty and IOL implantation. So if you are going to do triple procedures and you cannot accurately predict the power of the IOL, and you need to have an intraoperative measurement of the power of the IOL. Now, the aura or the optowave refractive analysis utilizes an intraoperative barometer that measures the power of the IOL inside the operating room. So this is another new technology added to the currently available methods for predicting the power of the IOL with high degree of precision and accuracy. It is named as aura or optowave refractive analysis. Now, after understanding what happened to the patients with the myopic LASIK ablations or hypermetropic LASIK ablations, and patients with radial keratotomy as far as the anatomy is concerned, and the changes that happens in the anterior and posterior surface of the cornea, when we decide to do a cataract surgery for those patients, we need also to know what type of IOL we are going to implant, because this issue has a special consideration in these patients. For example, usually we plan for a monofocal intraocular lens, and since it is a monofocal, we have to decide whether we have to implant a spheric IOL or not. Now, the answer for this question based on the fact that in patients with myopic LASIK or BRK ablation, they will have a positive spherical apparations, and this is induced by the laser ablation. So an ideal choice for IOL is to choose an IOL with a negative spherical aberration to compensate for the positive spherical aberrations. However, in hypermetropic LASIK ablation, which already induces a negative spherical aberrations, so we can use a zero spherical aberration IOL to keep the patient in the negative side, which presumed to give a better depth of focus for these patients. Now, as far as the toric IOL implantation, this can be within a very limited or restricted indications, provided that the central 3 millimeter zone of the cornea of that patient has a regular astigmatism over more than 2 measurements with more than 2 machines. So we have to have a stable astigmatism and regular. When we see we say regular, it could be an orthogonal or oblique astigmatism, but it should be regular within the central zone of 3 millimeter. And we should confirm this by more than one machine. At that time, the question of toric implantation is possible, provided there is no significant aberrations and high order aberrations in the patients, because if there is significant high order aberrations, better not to go for toric lenses. The same thing for multifocal IOL and extended depth of focus lenses. Better to avoid these lenses in cases post LASIK and post RK cases, because they already have high order aberrations, and these lenses will decrease the contrast sensitivity and decrease the quality of image of these patients. So better not to take the risk for implanting a multifocal or extended depth. Of course, these patients, when they decided to do myopic LASIK ablations, they are aiming for spectacle independency. So they will need also spectacle independency for near tasks. But we cannot compromise the distant vision for the sake of the near vision, because the patient will not be happy and satisfied, and the result will be unsatisfactory. So this is a brief. What are the considerations that we have to take care in patients with LASIK or RK after for IOL power calculation? So to summarize what we have said in the cases of post-refractive surgery regarding the IOL calculation, number one, you should take care of the keratometry reading, because post-myopic LASIK will induce changes in the ratio between the anterior and posterior surface of the cornea. So the keratometry should be properly matching the formula to be used, and ideally using the Scheimpflug technology to measure the total corneal power map instead of the presumed keratometric index, which is using the K reading from the anterior surface of the cornea only. Another thing, as I said, that the use of the AKR keratometry using the holiday report in the Pentacam is suitable in patients in post-LASIK, that we can incorporate this AKR reading in any standard IOL formula and have high degree of accuracy. Another thing that the AKR map, as I said, that can be used with any normal IOL calculation formula with high degree of precision, because it represents the central 4.5 millimeter from the cornea, which take in consideration the central 1.5 millimeter, where the maximum flattening that happens post LASIK cases. Now we come to the third scenario, which is measurement of IOL calculation in patients with keratoconus. As you know, the causes of visual degradation in patients with keratoconus can be due to the lens and can be due to the cornea. And as the cornea stabilizes by the age of 40 and 50, patient might have cataract. So at that cases, we might need to have special care to this patient to measure the accurate IOL power, and especially if we intend also to add toric correction for these patients. So we will discuss briefly about this subject. Now we come to the second important section, which is the relation between keratoconus and cataract. And when you have a patient with keratoconus and cataract and you are planning to do IOL implantation, what are the challenging points and what are the precautions that you have to take care? and what are the IOL formula that you are using, what are the parameters. All these points we will discuss in the coming slides. Discussing such a subject, that's the IOL calculation in keratoconus patient, is not surprising because there is a strong correlation between keratoconus and cataract. And patients with keratoconus who develop cataract, they will undergo much more degradation and deterioration in the visual quality. And by that time, they already have a stable keratometric parameters. So staging and grading of the keratoconus hair is very important to determine whether your patient is suitable for cataract surgery or not, and also to take the various measures to overcome the challenging points that I explain here, which is like the keratometric reading, which keratometric reading you are going to use, and axial length. Are you going to use an optical axial length or ultrasound axial length, or the different IOL power, which power you are targeting for emmetropia or myopia, and what IOL calculation formula you are going to use. So the Amsler Chromac system for keratoconus grading, which ranges from stage 1 to stage 4, up to stage 3, where there is no corneal scarring, this patient may benefit from cataract surgery. And actually, there are various studies done that demonstrate a significant improvement in the visual quality and of the patients after doing cataract surgery. Of course, there are various measures should be taken preoperatively as far as the wound construction, the location of the wound, and the healing process that might suffer this patient after cataract surgery. This is beyond the discussion in this lecture, but I will concentrate on the suggestive or the international standards as far as keratoconus patient. What are the indications for cataract surgery, and what are the measures that you are going to do to have a proper, accurate measurement for the IOL power. As you know, in keratoconus, as I have said earlier, the axial length is long, and also the AC depth is very deep, and this is create a problem in the IOL calculations. And some studies done shows the impact of errors in the axial length measurement exerts more error in the predicted post-operative result as compared to the error in the K reading. So in keratoconus, the measurement of the axial length is very important, and it should be as accurate as you can, and that's why the optical biometry is preferred as compared to the ultrasonic axial length measurement. As I said, that many studies done shows that the error or the impact of error in measurement of the axial length have much more impact on the prediction of IOL after keratoconus surgery, keratoconus cataract surgery, as compared to the keratometric readings. And as I explained earlier when we spoke about the IOL formulae, that most of the formulae, they are not doing well in extremes of the axial length. That's very high axial length. Most of the formulae, they are not very accurate in the extremes of axial length. That's why in keratoconus, we should targeting a myopic corrections, as I will explain later, and we have to accurately measure the K reading and the axial length to have a minimum refractive surprises. Now, this is also another study that shows the relation between the measurement with the optical ultrasound and optical biometry, and it shows the importance of the optical biometry in the measurement of the axial length more than ultrasound in cases of keratoconus. So what are the main challenging points in the keratometry reading in patients with keratoconus? As I have explained before, that the problem in the keratometry reading that we cannot rely on the SIM-K or in the that K reading that assumes the index of refraction, which is 1.337. This index of refraction was made for a normal cornea with a normal ratio between the anterior and the posterior surface of the cornea. This is the Goldstrand principle, and according to the reduced eye model. However, now in patients with keratoconus, now the ratio in the curvature between the anterior surface and the posterior surface is altered. So this index is erroneous. No more should be used because this will give you an overestimation of the K reading and lead to refractive surprises, mainly in the hyperopic side. So one of the challenging point, what K reading are you are going to use? So in such cases, you are better to use the real refractive index of the cornea with a keratometric reading that measures the total corneal power, that's the anterior and posterior surface, as seen in the pentacam using the total corneal effective corneal power, so that it can be used instead of the standard K reading, which uses the assumed refractive index, which is no more applicable in cases of keratoconus. Another challenging point is the asymmetry of the cornea. Make the central part of the cornea is not necessarily coincides with the visual axis. So in the standard K reading or the standard keratometry, it measures the central 3 millimeters. However, a large variation in the power of the cornea can be seen within the central 4 to 5 millimeter zone. So the standard keratometry is not that representing the real power of the central part of the cornea. Another point is the formula. Now, most of the formulae are based on a standard AC depth, and also they utilize an average axial length. And as I explained before, that most of the formulae, they are doing well in average size axial length. However, in the extremes, they have large variability and also large variation in the AC depth. So that's why this is another challenging point, which formula should we use to have an accurate prediction and avoid any refractive surprises. All of these points, apart from the surface problem, that patients with keratoconus, they have ocular surface problem. They have irregularity or instability of the tear film. So this is make another challenging point, especially if they are using a contact lens, either a soft or hard contact lens. So we need to stabilize the anterior surface first before we take any measurements from the anterior surface. So all these points leads to an overestimation of the K reading and also underestimation of the required IOL power, and will lead to a hyperopic surprises, and at the end both patient and doctors will be unhappy. So this is the major challenging points in the keratometry reading. Another important issue regarding the timing of the operation. Okay, after you have checked your patient and you decided to go for cataract surgery, now among the precautions and the measures that you have to do is what's known as the contact lens holiday. That if your patient is wearing a soft contact lens, you have, before you take the measurements of the biometric measurements, including the axial length and the keratometry, your patient should be stabilized by removing the contact lens for at least 1 week for a soft contact lens, and for a rigid gas permeable more than 2 weeks at least. And this is confirmed by stabilization of the keratometric reading, so that you will measure the keratometric reading every week. And when you find that there is reproducible and stable keratometric reading, at that time you will go for the take and accept the measurement. This is called a contact lens holiday. Of course, this might create some problem for the patient because he's suffering from poor vision from removing the contact lens, but this should be explained and discussed properly with the patient to understand the importance to avoid the contact lens warpage syndrome. Another thing is the issue of the measurements. For example, it is preferred to use the optical biometry rather than the ultrasound biometry, because in keratoconus it is difficult to determine the visual axis. Optical biometry is preferred in keratoconus. Also, the corneal topography in mild to moderate cases. Now, the corneal topography is more useful. As you know, the manual or the standard keratometer, which uses the SIMK and uses the central 3 millimeter from the cornea, will not reflect the real power of the cornea of the patient with keratoconus. And the use of the effective K reading is much more advised, as we have explained before in the lecture of the corneal topography. The effective K reading over 4.5 millimeter zone is more useful, because you will find the different powers within this zone in patients with keratoconus. So as I explained before, this is the topography map for the effective K readings, and over a zone of 4.5 millimeter is taken, and the peak here represent the EKR, and this EKR can be used with standard IOL formula, and we have to choose the proper IOL formula for these patients. So this is important measures should be taken pre-operatively to determine the biometric data for which we are going to calculate the power of the IOL. Now, what's the plan for the management for patients with the keratoconus as far as the IOL calculation formula? Now, based on different studies, it is advised that if you have a mild degree of keratoconus, mild to moderate keratoconus, that is between mild, according to the Amsler Chromac staging system, that is mild less than 48 diopter and moderate between 48 to 55 diopters. So in these cases, better to use the actual K reading of the patients, that's the true K. And the studies shows that in these patients with the mild keratoconus, they achieve 60% of the patients they achieve within 1 diopters of sphere equivalent post-operatively, and 41% of patients with moderate keratoconus, they achieve 1 diopter of post-operative sphere equivalent after using the actual K reading of the patients. However, for cases of severe keratoconus, it is that's more than 55 diopter. Now, these cases better advised to use the standard K reading, that's the 43.5 diopter, not using the actual K reading of the patients. And this one study shows the importance that in cases of advanced keratoconus, not use the normal K of the patient, but use the standard K readings. So it is like this, that if you have a preoperative K reading of less than 47 diopters, you can use the Holiday formula, the Hoffer Q, the SRK2 formula. And now it is important that all these formula, they will induce hypermetropia. After, if you put the standard measurements, you will end up by hypermetropia because they have very steep K reading and they have axial length. So it is advised that your target should be -1 diopter. So by doing -1 diopter, this will compensate the predicted postoperative hypermetropia that will occur. Now, if your patient is between 47 to 50 diopter K reading, now they found that the SRKT formula is very helpful in these patients, and your target refraction should be -1.5 diopter. If your patient more than 50 diopters, so better to make your target to be -1.8 diopter, and also the SRKT formula is useful. And in these cases, better to use the standard K rather than the patient's K reading. And of course, this data and this information based on different studies done, and one of them is these studies that suggest for this scheme for patients with keratoconus, because all the formulae will they have postoperative hypermetropia, so your target refraction should be targeting toward myopia. From the previous slide, that you can understand that the SRKT is still useful in the cases of keratoconus, provided the modification of the target refraction. And as you know, the SRKT belong to the third generations. Now, another study done to compare the new generation of IOLs, that's the 4th and 5th generation, with the old generations. And they did a study that comparing the Barrett for keratoconus using the TK value and also the EVO formula, and the Barrett for keratoconus using the standard K readings, and the 5th generation formula, that's the Kane for keratoconus, that's using the artificial intelligence. And they found that the Barrett for keratoconus using the TK has the minimum absolute predictive error, as you can see here, of around 0.117, followed by the Barrett for keratoconus using the normal K reading, and then the Kane formula. Although you can see that even the SRKT is holding well in this study, that it has a mean absolute prediction error of 0.27, which is comparable to that done by the Barrett for keratoconus using the traditional K reading. So generally, it is advised not to use the 3rd generation IOL so far, and better to coincide or stuck to the 4th and 5th generation IOL formula. This is as far as the 4th generation formula that's specific for the keratoconus, include the Kane keratoconus formula and the Barrett through K KC formula and the Holiday 2K KC adjustment. and they adjust their formula to be suitable for patients with keratoconus. As I said, the abnormal relation between the anterior chamber depth and the axial length make the prediction of the effective lens position is very difficult in these cases. So they made some adjustment and the modification in their constants in these formulae so that it can come up with a very low prediction error. Even though there is still some prediction error is there, but at least this is the most common formula used in keratoconus. And this formula, fortunately, the Kane formula and the Barrett through K formula can be used online. They are available online, and you can use them online if you have a case of keratoconus with cataract. Now, for you as a surgeon, it is not just the power of the IOL that bothers you, but also the type of the IOL. Now, you have a variety of options of intraocular lenses. The most common is the monofocal lenses that only correct the distant vision of the patients. And this is a preferred type of lenses in patients with keratoconus, especially when they have very irregular astigmatism. However, the option of the toric lenses is still there, provided the patient within the central 4.5 millimeter, he has regular astigmatism, as can be seen by corneal topography. For example, in this patient, you can see a very clear symmetric bow tie appearance within the central 4.5 millimeter. So in this patient, this is a suitable case for toric IOL correction in a patient with keratoconus. However, if the patient has irregular astigmatism and like this shape with inferior steepening, now this is not a good suitable case for toric IOL calculation, and better to go for monofocal lenses and discuss with your patient the post-operative rehabilitation using glasses or the contact lenses after the surgery. Now, the option for premium type of lenses, that's the multifocal lenses or the extended depth of focus, this is out of question in cases of keratoconus because these patients, they already have high order operations, and better not to go for this type of lenses, as this will dramatically lead to patient unsatisfaction and decrease in the image quality, as they itself is decrease the contrast sensitivity of the image and increase the aberration itself in these patients. So it is not accepted to implant premium type of lenses in patients with keratoconus. So better not to go, because this will induce more aberrations to your patients. So as a generally, the monofocal lenses is a best option for them, and toric lenses is under limited restriction, provided the patient have very regular astigmatism within the central 4.5 millimeter zone, and the premium type of lenses is out of question, and better not to go for it. Okay, what about the spherical aberration? You choose a monofocal lens, but you still need to know whether to choose a monofocal lens with positive spherical aberrations or with negative spherical aberrations. As we have explained in the lecture of corneal topography, that most of the normal people, they have a positive spherical aberrations, and by positive we mean that the peripheral rays will be focused in front and the central rays will be focused in the back. And this will create an airy disc with a focus in the center and a different circle of blurred around it. So this is called the positive spherical aberrations. And negative spherical aberrations means the reverse, that the peripheral rays will be focused in the back and the central rays will be focused in the front. Normally we have a positive spherical aberrations, and usually we improve this spherical aberration by implanting a negative spherical aberration lens. However, in case of keratoconus, they have severe negative spherical aberrations, and if you implant a spherical lens with negative spherical aberration, you will worsen the quality of the vision of the patient. So better in such cases that you implant a positive or a zero power spherical aberrations, either a zero power or with a positive spherical aberrations, so that you will compensate or neutralize the severe negative aberrations that they have. But always better to keep the patient in a mild degree of positive spherical aberration. They claim that this will increase the depth of focus and increase the reading of the patient. Although this issue is out of importance in patients with keratoconus, as our quality, our target or our aim to have a better monofocal distant vision, and for near he will use glasses or use a contact lenses. So better we aim in case of keratoconus to neutralize the high degree of negative sphere calibrations by implanting a zero sphere calibration or mild positive spherical aberration lenses. So to sum up what we have said before, that the issue of axial length measurement in keratoconus is very important, and it is advised to use the optical biometry for proper and accurate measurement of the axial length, because it can determine the visual X properly, and avoid using the ultrasonic axial length measurement. Now, the issue of keratometry, as I said earlier, if your patient mild to moderate keratometry, better to use the K reading of the patients and avoid overestimation of the K readings. And if your patient is very severe keratoconus, so better to use the standard K reading, that's 43.5. And you can use the effective K reading from the pentacam, as that K reading can be used in any IOL calculation formally. The other thing, as far as the IOL calculation power, you should targeting a myopic correction for these patients, because they have high chance for hypermetropia after correction with IOL. So your target should be towards myopia, and use of the SRKT formula and the Kane formula is, and also the Barrett Universal 2 formula is useful in these patients. And as far as the type of IOLs, better to go for monofocals and toric IOL under limited or restricted indications. However, the extended length or the premium lenses is prohibited in keratoconus. Now we come to the last special case scenario in IOL power calculation. That is IOL power calculation in pediatric age group or in pediatric cataract. The subject also is important and has special consideration because of the variability and changes in the axial length and keratometry over time as the child grow up. So we will in the next slide speak about these situations. Now we will speak about one of the important subjects, which is regarding the IOL calculation in pediatric age group. This is very important subject, even the huge advancement in the management of adult cataract as far as the prediction of IOL power calculation, as well as the improvement in the technology and the machines. Still, the pediatric cataract is lagging behind, and this is because of the many challenging points that confront the surgeon in these type of cases. The pediatric cataract, you are dealing with a dynamic structure that is changing in the axial length and changing the keratometry over a long period of time, reaching up to the 8 years. So this is represent a strong and important challenge to the surgeons to achieve a satisfactory result and emmetropia after cataract surgery. So the main challenging points in congenital cataracts is you have a challenging point as far as the keratometry and the axial length. As I said, the axial length is changing and the keratometry is changing. You have a challenging regarding the ideal IOL calculation formula and the target refraction required based on the age of the patient. For each age, you need a target refraction. In such cases, we are not aiming for emmetropia. However, we are aiming for hypermetropia based on the age of the presentation or the surgery of the patients. Another thing about the choice of the IOLs and the types of the IOLs suitable for such cases. And also, we should understand all of these variables along with the normal myopic shift of the patients. As you know, these patients or these children are born with hypermetropia, and based on the principle of emmetropization that I have spoken about it before. So there is a calculated myopic shift, and we should respect this myopic shift to achieve good growth of the eye. And at the end, we should take in consideration that even after IOL implantation, you still need strict post-operative rehabilitation of the patients for other issues like the post-operative astigmatism after surgery, and sometimes you need to add glasses for the patients or contact lenses on the top of the IOLs because of the unpredicted errors or any refractive surprises. So all these issues are very important and represent a big challenge to surgeons to achieve a satisfactory result for these patients. To understand the challenges that faces the doctor for the choosing the proper IOL calculation formula and the ideal IOL lens that should be implanted, we should understand the normal growth of the eye and the principle of immetrobization. Now, as you can see, this is the famous graph that shows the growth of the eye. It is the growth of the eye is triphasic. Triphasic means it has a very rapid increase in the axial length within the first 2 years of life, and then a moderate increase in the size of the axial length between 5 to 6 years, reaching up to around 0.4 millimeter per year, and then slow down and after the age of 6 years, so that it is around 1 millimeter per year. So this is a triphasic pattern of the increase in the axial length of the child who is born with an axial length of around 16.6 millimeter, and it will reach by adulthood after the age of 8 years to around 23.6 millimeter. So also similarly, the same changes will happens in the keratometry. When the child is born, he born with very steep cornea reaching to the power of 51.2 diopter, and at the age of 8 years he will be around 43.5 diopter. So you can see that there is what's called immetrobization. Now immetrobization means that there will be an increase in the when the child is born, he's already hypermetropic, and this hypermetropia is the trigger for the increase in the axial length of the eye, and this is very important concept, should be understood. Now the presence of the hypermetropia, this will trigger some factors that lead to the increase in the axial length of the eye, so that there will be a myopic shift to neutralize the pre-existing hypermetropia, and at the same time there will be flattening for the cornea, which already he's born with a very steep cornea. As I said, the power reaching up to 51 or 52 diopters. So within the first 6 months, it will decrease by around 3 or 4 diopters within the first 6 months. The maximum flattening or the maximum flattening of the cornea appears within the first 6 months. So this flattening will have a hyperopic shift, and the increase in the axial length will have a myopic shift. But the overall result, there will be graded and gradual calculated myopic shift, so that by the age of 8 years, the child will have nearly emmetropia. And this is very important. Very important in the sense that if we do cataract surgery and we keep the patient aphakic, so this aphakia will disturb the whole process of emmetropization, and this will lead to triggering this hypermetropia, will trigger more increase in the axial length. That's why we notice in patients who are not implanted with IOL or using glasses after surgery, they will have severe myopia and increase in the axial length when they grow up. So this principle should be understood, that we shouldn't keep a child aphakic if you can, and you better to manage him even after surgery, either with glasses or contact lenses, and don't forget the management of amblyopia after surgery. So this is a general overview about the natural normal growth pattern of the child's eye. When he's born, he's a severe hypermetrop, and as he grow up, by the age of maximum increase in the axial length will appear in the first 2 years of life, and then a moderate increase in the axial length will appear between 2 to 5 years, and then a slow or plateau increase in the axial length after the age of 5 years. This is the natural and normal change in the axial length. The other important challenging point in the pediatric cataract, as I said in the introduction, is the target determination of the target postoperative refraction and the calculation of the IOL power. Now, in view of the principle of immetrobization that I have explained before and the myopic shift that will happen after the surgery according to the age of the patients, so there are different protocols and regimes designed to predict the post-operative undercorrection needed so that by the age of 8 years, the patient will reach to the ideal immetrobization. But this is very dynamic principle and is not accurate 100%, but to a large extent, there is one of the most accepted protocol or regimes done by INYADI, which is known as Rule of 7. Now, Rule of 7 stands for that we add the age of the patients to the desired postoperative refraction. This should be equal to the 7. So if the child is age 1 year, so the desired postoperative refraction should be plus 6. So in the IOL calculation formula, you will put the desired postoperative refraction plus 6 so that the IOL power coming is the one which you are going to implant. If the age is 2 years, so you have to implant the desired postoperative refraction should be plus 5 and so on. So this is known as Rule of 7, done by Yadi et al. At 1998. This is one of the famous one which is gained acceptance by most of the surgeons. Of course, there is a lot of regimes, but still there is controversy among them, but this one has gained acceptance by most of the surgeons. Another point I would like to say, to emphasize, is that when we say, for example, we aim a hypermetropia of desired postoperative refraction of the plus 6 diopter, when you calculate the IOL power, for example, you aim for immetropia first, so you put the desired postoperative refraction is 0, so the power comes for you, for example, 22. So if you are aiming to the desired hypermetropia plus 6, you will detect 6 diopters from this IOL power. This is wrong. You should not do this because this will lead to error in the calculations. However, what you will do is that from the beginning, you put the desired postoperative refraction is plus 6, so that you will find the end power needed is 16. Previously, 22, if you detect 6 diopter from the 22 diopter, it will be around 18 diopter. However, when you put the desired postoperative refraction plus 6, so the result comes to you is 16. So this is an important point, that immediately you put the desired postoperative refraction, and whatever result come to you, this is the power of the IOL that you are going to implant. Now, the other challenging point that I have spoken in my introduction is about the choice of the IOL power calculation, and also about the measurement itself. I will not speak in details about the advantage of IOL master or the optical biometry over the A-scan biometry or immersion technique to measure the axial length, as I will explain in this in a separate lecture. But of course, all of us know that the optical biometry has high degree of prediction and accuracy as compared to the ultrasound biometry. However, sometimes the IOL master is not available in many hospitals, and also it is difficult to use it during general anesthesia because you need to measure the axial length sometimes under anesthesia. So the choice of ultrasound is there. So this should be important that we have two common formula shows high degree of accuracy in children because they have short axial length. That's the SRKT formula and the Barrett 2K formula. And the Barrett 2K formula, when you use or measure the axial length using the optical or IOL Master 700, you can use the Barrett 2 Universal 2 formula. And if you use the ultrasound, better to go for SRKT formula. So these two formulae are very common in pediatric cataract. And in very short eyes, you can use the Hoffer Q formula either in ultrasound or IOL master calculation of the axial length. So this is another challenging point in pediatric cataract. That's the IOL power formula, as well as the measurement technique using the optical ultrasound or the optical biometry or the ultrasound biometry. بهذا القدر نكون قد وصلنا إلى نهاية الجزء الثاني من محاضرة ال IOL Calculation Formula Update and Recent Advances. أتمنى أن أكون قد ساهمت في إيصال الفكرة في Recent Update in the IOL Calculation. إن أصبت فهو من الله سبحانه وتعالى، وإن أخطأت فهو من نفسي ومن الشيطان. أتمنى أن ألتقي بكم في محاضرة جديدة. إلى ذلك الحين أستودعكم الله، والسلام عليكم ورحمة الله وبركاته.